Assalamu alaikum, my name is Jawad Ahmed and today I'm going to walk you through how the digital scale works, their working principle, and in the end we are going to analyze and review one of the digital commercial scales available on the market. So we use scales in almost every facet of our life, from purchasing goods to industrial manufacturing and everything in between. Now let's see how does the scale work. So instead of looking onto a specific digital scale, I'm just going to be discussing digital scales in general, because almost all the scales available in the market have the same general principle, working principle. So almost all scales rely on devices called load cells to physically measure how much an object weighs. Here is shown a typical load cell. They can be round or in other shapes, but they have the same working principle. When weight is applied to a scale, the load cells bend slightly, causing an electrical signal running through the load cell to change. This analog signal change is due to the amount of electrical resistance the bending causes to a small device inside the load cell called strain gauge. So when the weight is applied, this load cell bends and its bending is detected by the electrical resistance changes in this device. And when its resistance changes, the electrical signal that was the electrical signal that it sends to this device changes, and it is calibrated as such to calculate the weight according to the change. So let's discuss this strain gauge, as it plays a very important role in measuring the weight. Now, strain gauge measures strain by means of a change in resistance. As you can see, a foil pattern that is mounted on a flexible substrate. The substrate also serves as an insulator, and the current is run through the foil. When it is put under compression or tension, there is a change in resistance which is proportionate to amount of deflection. As you know that the resistance in a conductor is inversely proportional to its cross-sectional area. So its foil resistance depends upon its the cross-sectional area also, and when it is stretched, the foil narrows and its resistance increases. When its resistance increases, the electrical signal decreases, and when it is compressed together, it thickens and the resistance decreases, and the output signal is given as high. So that's how the strain gauge works, and it is commonly used in the Wheatstone bit configuration, so that any changes in any one of the strain gauge is detected and converted into the weight change by the device. So back to the load cell. The load cell's analog signal change is then read by an electronic device and turned into a digital weight scale. Here, this is the electronic device, and in there is a microcontroller that takes the analog input by the load cell and converts it into a digital output. This then it reads the digital pulses and processes the data to calculate weight, that is then displayed on the LCD screen here. So there is the general working principle of the cell of the digital weight scales. Now, depending upon the complexity of the scale and digital weight indicator, the weight value that was determined can be part of complex processes. Complex processes such as, here, checking weight, weighing packages on a conveyor belt, on a manufacturing conveyor line. Here, parcels are weighted, and the parcel which weighs less or more are then rejected. And the second one here is sending weight data to automate a batching process. And the third is weighing truckloads as a part of a logistic transfer operation. So these all are common examples where scales are used. And now we're going to be discussing and reviewing a product. It is a digital weight indicator for silo tank and vessel weighting. As you can see here, it is a 7-digit scale, so it can measure very heavy substances, and it is a high resolution, and it is approved by a very standard organization. Now let's see its data sheet. First of all, there is given its resolution, 24-bit analog to digital converter. AD stands for analog to digital converter, and in I will say it's quite a bit resolution because most devices use like 8-bit, and it is a 24-bit, so it has high resolution. And resolution is directly depends upon its external divisions, and you can see there is 100K external divisions, so even a small change in the weight is detected here. So now excitation, you just need 6 volt to excite it. The AC power supply should be to 30 volt. Here the tolerance is given plus minus 10. It can tolerate the to 20 or to 40 volts AC, and the DC supply is given 12 volt, and again its tolerance. Now approval. It is approved by International Organization of Legal Metrology, OIML, and it alone is a very heavy standard organization. And then here are network comms and serial comms. These are actual telecommunication standards, so it follows these standards. And you can see here the analog outputs. It gives its output, it's the ranges and spans of its outputs. It can give an output in between 0 to 5 volts, 0 to 10 volts, 0 to 20 milliamperes, 4 to 20 milliampere, auto isolated. And you can see that enclosure, it is enclosed in a stainless steel so that it don't bend. It is a stainless steel, it won't rust, it won't bend. So it is a very it is very good to use commercially in silo tanks. And display digits, readings per second, and cable gland and terminal connections. It is hermetically sealed. Hermetical sealed means it is airtight. And you are working in a silo tank, then there is going to be a dust everywhere, and you need airtight connections. Environmental protection, IP65. Now IP stands for ingress protection. IP6 is rated as dust tight and protected against water projected from a nozzle. So it is ideal to be used in silo, tank and vessel weighting. So thanks for watching my video, and inshallah we'll